MAT193 in class activity 20A, red plastic cup. In today's activity, we will think about how to find the volume and surface area of a solid shaped like a plastic drinking cup. First, let's consider this scenario. Take a two 8.5 by 11-inch sheets of paper. Roll one sheet along its long axis, joining its 11-inch edges to make a long, thin cylinder. Roll the other sheet the other way, joining its 8.5-inch edges. Which cylindrical surface do you think has the greater surface area? If the cylinders were given tops and bottoms and filled in, creating cylindrical solids, which do you think would have the greater volume? Now, in the first scenario, what we are doing is that we are having a very thin cylinder, which will give us a height of 11, and the circumference of the base is going to be 2, which is 2 pi r, is going to be 8.5. Now, in the second scenario, we are going to have a shorter cylinder, right, with height 8.5 inches, but then the circumference of the base, which is 2 pi r, is going to be 11 inches. Now, what we want to do is to find which cylinders has the greater surface area. So I want you to consider this, pause the video, and come up with possible answers, and let's discuss this later on. Now, if you look at the two cylinders, you will realize that the surface area of a cylinder is 2 pi RH. And whichever way you look at it, when this becomes a 2 pi r and that becomes your h, you get the same surface area as that. So the surface areas are going to be they are going to be the same. Now, if the cylinders were given tops and bottoms and filled in, creating cylindrical solids, which do you think would have greater volume? Now, this one, the volume is 1/3 pi r squared h. And so it depends on these ones, the volumes are going to change, because in this case, one of these radius, if you find a radius here, one of these is going to be squared and the other also is going to be squared. But the one with the bigger radius, when squared, will make that volume bigger, and we will delve into this later. Objectives for the activity. You will understand that two cylinders may have the same surface area but different volumes. You will be able to calculate the surface area and volume of a cylinder, then calculate the surface areas and volumes of cones and frustums. Volume and surface area of a cylinder. If a cylinder has a base radius r and a height h, the volume of the surface area, excluding bases, are given by the formulas V equals pi r squared h and A equals 2 pi r h. Now calculate the volume of the two cylindrical solids described in question 1, part B, which has the greater volume. Justify your answer. I want you to pause this, knowing that one had a height of 11, a circumference of base 2 pi r of 8.5. The other had this to be 8.5, and then 2 pi r of the base to be equal to 11 inches. So use these two to calculate the different volumes by pausing the video, and we will discuss this later. Now, if we take the thin one where the height is equal to 11 inches, The circumference of the base area is 8.5. You will see that 2 pi r is equal to 8.5. So r becomes 8.5 over 2 pi. This gives us a volume of V to be equal to pi r squared h. So initially I said a volume of 1/3 pi r squared h. That is wrong. So a volume of pi r squared h. And when you find that volume, you get 63.25 cubic inches. Now, by similar reasoning, the second cylinder, the shorter cylinder, is going to have a 2 pi r to be equal to 11, to be equal to 11 inches. So r becomes 11 over 2 pi. And its volume, V, also becomes pi r squared h. Now, when you find the volume for the first one, you get 63.24 cubic inches. And then for the second one, you get 81.85 cubic inches. And so you realize that the radius, the bigger radius, the bigger the radius that you get, the greater the volume. A red plastic party cup has height 11 centimeters. The diameter of its solid base is 6 centimeters. The diameter of its open top is 9.5 centimeters. You will calculate the volume of the cup. If the cup is flipped upside down, you might recognize its shape as a large cone with a base diameter of 9.5 centimeters, from which a smaller cone with a base diameter 6 centimeters has been removed. This shape is called a frustum of a cone. Use similar triangles to find the height h of the cone. And so part A is use similar triangles to find the height h of this cone. And then part B, you want to find the volume of the cup. Number 4. In general, the volume of a frustum of a cone is given by this formula. That is pi V equals pi on 3 r squared, which r is the radius of the smaller part of the frustum. And then big R is the radius of the bigger part of the frustum. And then h is the smaller height. H. So where is the height of the frustum, and R are the radii, the circular top and bottom. Does this formula yield the same volume as the one you derived in question 3, part B? So I want you to pause the video and consider all these questions. Take them one after the other. Try your hands at them, and let's discuss your solution together. Now, we want to try this question using similar triangles to find the height h of the cone. Now, if you look at the height h, we are going to divide the height h by, from here, you can see that another h of this one, the smaller top of the frustum, is this height h minus 11, because from here to there is 11. So we are going to say that by similar triangles, h over h minus 11 should be equal to the base of the bigger one, which is 9.5, the radius here, which is 9.5 over 2, which is 4.75, divided by the radius of the top, which is 6 divided by 2, which is 3. And when we cross multiply, we are going to get 3h to be equal to 4.75 h minus, now when we multiply 4.75 by 11, 4.75 times 11 That gives us 52.25 minus 52.25. Now, when we see that we are going to get 52.25 to be equal to 4.75 minus 3, and that gives us about 1.75h. And when we divide through by 1.75, we get h to be approximately equal to 29.6 centimeters. Now we want to find the volume of the car. That is, we want to find the volume of the frustum. Now the volume of the frustum, we can calculate this as pi h over 3, the bigger radius cube minus smaller one cube, all over 3. And when we do that, where big R is equal to 4.75, we are dividing this is the diameter, divide the diameter by 2, we get 4.75, and then R is 6 over 2, which is 3, and then H is this distance, that is 29.86 minus 11, 29.86 minus 11, that gives us 18.86, and then all divided by 3. When we calculate this, when you put all this in this expression, you are going to get V to be equal to 527.72 centimeter cube. And the last part of the question is that in general, the volume of a frustum of a cone is given by this formula, where h is the height of the frustum and r and big R are the radii of the circular top and bottom. That this formula yields the same result as the one you derived. Yes, it does. And so when you put in these values in here, you'll see that you get the same result as that. If R equals R, the frustum or the cone becomes a cylinder, verify that if you replace big R with small r in the volume formula above, you obtain the volume formula for a cylinder. I want you to pause this video, try your hands at this question, and let's discuss it later. Now, if you remember, the formula for the volume of the frustum was small r squared plus small r big R plus r squared. We want to replace R to be equal to small r. So this gives us the volume to be equal to pi over 3 small r squared plus small r times small r. We are replacing that plus small r squared h. And this gives us r squared plus r squared plus r squared h pi on 3. And this is 3 r squared h times pi on 3. This cancels that, so we get pi r squared h, which is the volume of a cylinder as above. Thank you for watching.